Hi and welcome to the PowerEgg YouTube channel. In this video we are going to compare two Power BI DAX table functions that are relatively new, the window function and the offset function. We're going to do this by yielding the same result for both functions, which are two tables that show the current year sales versus the previous sales based on the manufacturer name partitioning. Thank you very much for watching and please subscribe for more. Right, so straight into Power BI, let's have a look at the two tables. As you can see here, I've already added them. On the left hand side we have the offset table and on the right hand side we have the window table. The offset table is based on the offset calculation and the right hand table is based on the window calculation. So in order to add a calculated table with the DAX code that you need, you have to click on the modeling ribbon and then on the new table menu, and it will open up the DAX menu where you can add the DAX code as needed. So let's have a look at that DAX code. So I will open up the data menu and click on the offset table to see the code, which is at the bottom. And you can see here the offset table is defined as will follow. So we first define a variable which calculates a table for our context that we're going to use later in our calculated table DAX code. And what it does, it groups, it summarizes columns by creating a table. And this table is created from two columns from two different tables that have a relationship. So it is important in your data model that you have the existing and working relationship between these two tables. In this case, there are two dimension tables, first the date dimension table and then the product dimension table. So I'm grouping I'm grouping these two tables by calendar year and manufacturer name, and then adding a further calculated column called current year sales, which is based on the total sales measure, and it is rounding this value up to 2 decimal places. Just a quick note, if the rounding up results in a concurrent number, so for example here on the bottom you can see here that the current year sales is has more than 2 decimal places. This is because it wasn't able to round this up properly, and then we can use truncate or define in the Power BI menu that we want 2 decimal places to cut this cut the further decimal places off. But returning to the DAX code, so first we define our variable, then we need to add the return code in order to define the calculation that we want to calculate our table. And we are adding a column to the previous table that we calculated, which is defined here in the variable name vtable relation. So will return all the table columns from the previous calculated table and adding it. And then adding a further column to this table called previous year sales, which we are defining after a comma. So you would have to write comma and then define the column that we have for the previous year sales, and it is using the offset function. So we are selecting the columns from this table, ordering it by manufacturer name and calendar year. This is important to have the right context, so it knows that we want to offset, so -1, move up 1 row from relative to where we stand currently based on the partition that we defined inside the code. And in this case, we're partitioning by manufacturer name, sorted on the year and manufacturer name column. So it will return, for example, 2007, 2008, 2009, as you can see here in the bottom. Then we have the manufacturer name. And then we have, as defined in the variable, our calculated column called current year sales, which is based on the total sales measure. And then we are going up relative to where we stand. So for example, if I would have 2008, I would check the current year sales column, go up relative to where we stand, and take that measure value and return it in the new column called previous year sales on the row right to where I stand, which is called previous year sales. And again, we are rounding it up by 2 decimal places. And because we are partitioning by manufacturer name, if we see the first value, it returns blank. This is because we partitioned by, so we are taking out a partition from our data table, and which is based on the manufacturer name, and the function would try to go up one step to relative to where we stand, which would return blank because there would be nothing inside this partitioning. This is why we have a blank in the column for the first value. If we wouldn't partition it by manufacturer name, it would go up to the previous manufacturer name and return the result for that manufacturer name, and it will give us an unexpected or incorrect result. All right, so let's have a look at the window table function. Let me click on window table and expand the DAX code. You can see that the first thing we are doing again is defining a calculated table in a variable, and again combining the two tables, product and date, and taking and summarizing it by calendar year and manufacturer, or grouping by. And we are adding a current year sales column based on the total sales measure, and again rounding it up by 2 decimal places. Then we add the return code to define the calculated table that we want, again using the add columns because we want to add the columns based on the window function, again called previous year sales, to all the columns that we are returning from the previous variable table calculation. And we are wrapping a sumx around the window function to get a row context value, and in the window function we are going back one step relative to where we stand. And basically this is a start and end definition which would return a window, so kind of like a partitioning, if you want, from within that data table. So I'm using -1 relative to where we stand. You can either choose absolute, so an absolute positioning. So if you would always want to start at the same point inside the window function, you would use absolute. But I want to go back dynamically, so relative to where I stand always inside this partitioning, so going up 1 row based on the order that we have defined earlier. So again, order by calendar year and manufacturer name, and then partition by manufacturer name, go back up relative to where we stand 1 row, and return the result from the current year sales and give it 2 decimal, round it up to 2 decimal places, and call this new calculated column previous year sales. So let's have a look at the performance from both of these calculations and compare them. If I would click on the offset table, the first thing I have to do is click on the optimize ribbon menu. So I'm clicking on optimize here. I have to open up the performance analyzer. So let's click on performance analyzer, and we do this to optimize our report to see which visual is performing better or worse, to perhaps adjust them accordingly as needed to give the user experience the best that we can. So let's click on start recording first, and then we have to refresh our visuals. This is going to refresh all the visuals that we have in this page, and I'm going to click this a couple of times to see which one performs better the most times. So I'm going to click on refresh visual. The first thing we can see here is that the offset table is around 30 milliseconds faster than the window table. Let's click this again. See, we can compare the result. Again, a similar result. Let's click this again, and again, and again, and again, and again, and again. And we can do this a couple of times, and we can see that all in all, we have more times the offset table function performing better than the window table function, although there are 2 exceptions here inside. So sometimes this performs differently. Of course, this also depends on what machine I'm using, because I'm doing this in Power BI Desktop. But to finish, we just click stop. And if you want to try this again, you just click on clear result, click on start recording again, and then do this a couple of times again, just to see perhaps the result will be different. And again, we have something really similar, but in general, the offset table is performing better than the window table function. So thank you very much for watching, and I hope to see you next time.